In this video, we're starting section 3.3 on graph transformations. Our goals are to sketch a graph using transformations. So things like reflections and shifts. Okay, so in this video, I want to focus on what type of thing can cause a reflection and what type of thing can cause a shift when we look at a function's formula. So I want to get right into an example where we sketch a bunch of curves. And in each part, I want to describe how each curve that I'm going to draw compares with the graph of f of x equals square root of x. So that is going to be my original function here, and then I'm going to start to tweak the formula. So if I draw some axes, recall, well, what does a graph of square root of x look like? Well, it's got this initial point here at the origin, and then it starts curving upwards like this. So then this initial point at 0, 0, and then it curves upwards like that. And let me label one other point on the graph. If I plug in 4 for the x coordinate, what I get out is 2 for the y value. So the y value is 2, so it goes through this point 4, 2. Okay, so let's first consider what happens to the formula if we were to look at y equals negative square root of x. So y equals negative square root of x. Well, what happens there is that we are going to reflect the whole graph across the x-axis. So it's going to flip the whole thing down. It's going to flip the whole thing down, so it looks like this. And I could sort of verify that if I were to plug in the same x-coordinate 4 in here. Well, square root of 4 is 2, but then this negative sign in front of it makes it so that, well, the output now is negative 2. If I plug in 4, I'm getting negative 2, and that corresponds to a point down here in the 4th quadrant. So it makes sense that the y values now have all become negative for this graph. So the more general rule here is, if you have a formula, and you end up, and I call it f of x, and I end up sticking a negative in front of the whole formula, it reflects my graph across the x-axis. Okay, all right, let's look at part B. What if now the negative is inside the function next to the x? So generally, I'm taking my f of x, and what I'm doing is I'm changing the x that's inside the function to a negative x. Well, that's going to reflect the graph across the y-axis. It's going to reflect it across the y-axis. So graphically, when I do that, it flips the whole thing across the y-axis. Now that's going to look like this. And I could test that. I could test that because, well, now if I plug in the number negative 4 for x, so x is negative 4, but then this other negative turns that into a positive 4. And if I square root positive 4, well, the y value is 2. So now when x is negative 4, the y value is 2. And if I were to plug in, you don't have to draw this in your paper, but if I were to plug in 4 for x, well, I would get square root of negative 4, and that's undefined. And that's why when x is 4, there's no point on the graph over here in this region. Okay. Alrighty, so now finally part C here. What if I were to throw 2 negatives in there? So not only am I changing the x to a negative x, but I'm also putting a negative in front of the whole thing. So that's going to do both of those reflections across the x-axis and across the y-axis. So if I do it across the x-axis first, if I do this one first, and then I flip it across the y-axis, I'll get the mirror image of that, which is down here. It also turns out I can consider in the other order. If I did it across the y-axis first, which was this, and then I flip that whole thing across the x-axis, is down here. Okay, so I'm going to draw that graph. So reflecting it across both axes. I can describe that more succinctly as simply saying it's going to reflect the whole thing across the origin. Okay, because putting in both of those negatives, that's changing not only the sign of the x-coordinate, but also of the y-coordinates on the graph. And that reflects the whole thing across the origin. Okay, let's move on to example 2. Okay, same idea. I have a bunch of specific formulas that I want to consider and look at what happens. And then I want to describe the more general rule above. Okay, so part A. What if I have square root of x and I add 4 to it? Well, that is going to shift the whole graph up. That is going to shift the whole graph up. In this case, it's going to shift it up by 4 units. Okay, so that initial point, instead of having the y-coordinate being 0, it's going to be 4. And then the same curving shape like this. And I could verify that. Like if I were to plug in 0 for the x, I get square root of 0, which is 0, plus 4, which is 4. So the y value at this starting point should be 4. Okay, on the flip side, if I were to have subtracted 4, it's going to move the whole thing down 4 units from where I started. So now the starting point, the y value there is negative 4. And then I have the same curving upward shape. Okay, so the general rule for if I add some number at the end of my formula is the whole graph gets shifted up by a, by whatever that number is. And when I subtract some number at the end of my formula, subtract some number a, the whole function gets shifted down by a. In this case, it got shifted down by 4. Okay, the other type of thing that could happen is, well, what if the x that's inside of the formula gets replaced with like an x minus 4, if it's replaced with an x plus 4, but that's happening inside of the function. So like right next to where the x was inside the function, that's happening. I'm changing it to x minus something or x plus something inside the function. Okay, so let's say for part C, I wasn't sure what happened. It's going to be some type of shift, I'll say that right now, but let's say I wasn't sure which direction it's going to shift it. One way I could verify it is by plugging in a value. Like in the original function, the starting point happened when I was doing the square root of 0. So what would I have to plug in for the x here so that I end up with square root of 0? Well, I would have to plug in positive 4. So when x is positive 4, that's when the y value is going to be 0. So that's going to be the point here, 4, 0. So that means that in my initial graph, well, the starting point was here, the origin, it's got shifted to the right. So same square root shape, but the whole thing got shifted to the right. I'm shifting it to the right. So in general, if I replace the x that's inside the function with x minus a number, it's going to shift the whole graph right by a. Okay, so now, well, if I were to replace the x inside the function by x plus a, it's going to shift the whole thing left by a. So if I have square root of x plus 4 with the x plus 4 inside the function, inside the square root function, well, it's going to shift it left. So now it's going to be starting at negative 4. And again, still have that same shape. I could verify that that makes sense by, again, thinking about what would I plug in for x so that I end up with square root of 0. And I would have to plug in negative 4 in for x to get square root of 0. Okay, so that checks out. So in the next video, we'll focus on applying these rules about when I reflect and when I shift things to tackle more multi-step examples, when we will need to do combinations of shifting and reflecting to graph something step by step. We'll tackle that in the next video.